Good morning, friends. So we'll start ASME section 5, Article 7, Magnetic Particle Examination. So T710. In general, this article is in conformance with SC 709, Standard Guide for Magnetic Particle Testing. General. Typical types of discontinuities that can be detected by this method are cracks, laps, seams, cold sets, and laminations. Lamination that is open to on the side when after bevel. Otherwise, it cannot. Only UT. You understand lamination? You can. Or you see my video, chapter 13 for ASME level 3. You'll understand what is laminations. The requirement listed in T721 procedure qualification. Same equipment T750. Examination medium, particle type, fluorescent pigment or non-fluorescent pigments or both. So particle is dry and wet particle. With these two, you have dry and wet. But dry particle doesn't have fluorescence, only wet. Temperature limitations. Particles that are used within the temperature range limitations set by manufacturer of the particle. So they are writing everything. Alternatively, particle may be used outside the particle manufacturer's recommendation, providing the procedure is qualified in accordance with Article 1 T150 at a proposed temperature. So this procedure qualification is nothing to do with you, but still you should know what is the requirements of a magnetic particle examination procedure. So magnetizing current type, amperage outside range specified by the article or as previously qualified. You can make it bigger, small. So magnetizing technique. Magnetizing current type, amperage outside range specified by the article or as previously qualified. Surface preparation, magnetic particle, fluorescent, visible, color particle, size, wet, dry, method of particle application, method of excess particle removal, minimum light intensity, existing coating greater than the thickness demonstrated. The coating thickness it is talking about, non-magnetic surface contrast enhancement when utilized. So if you are utilizing it is essential variable. All these are essential variable. Non-magnetic surface contrast, performance demonstration when required, examination part surface temperature outside the temperature range recommended by the manufacturer or the particle or as previously qualified. So essential variable means if you change anything from here, then you have to re-demonstrate your procedure. So that is the only difference. Shape and size of the examination object, equipment of the same type, temperature within those specified by manufacturer. No problem. You can test any temperature within that one. If you're changing that one, then you have to requalify. Post-examination cleaning technique, demagnetizing technique, personal qualification requirement. That is not to do anything with. These are non-essential variables, so no problem. You can do anytime as you wish. So you can change all these things as per company rules, as per company written practice, you can say, because last one is qualification. So it is depending on written practice. Surface conditioning preparation. However, surface preparation by grinding or machining may be necessary, where surface irregularities could mask indications due to discontinuities. Prior to magnetic particle examination, the surface to be examined and all adjacent areas within at least 1 inch 25 mm shall be dry and free from all dart, grease, lint, scale, welding flux and sputter, oil or other extraneous matter that could interfere with the examination. Detergent or inorganic solvent, descaling solution, paint removers, vapor degreasing, sand or grit blasting, or ultrasonic cleaning methods cleaning may be accomplished by. So non-magnetic coating are left on the part in the area being examined. That is problem. It shall be demonstrated that indications can detect through the existing maximum coating thickness applied. Where AC yoke technique is used, the demonstration shall be in accordance with mandatory appendix I of this article. Non-magnetic surface contrast may be applied by the examiner to uncoated surface. Techniques: Prod technique, longitudinal magnetization technique, circular magnetization technique, yoke technique, multidirectional magnetization technique. So magnetizing current, prod technique, because that is for this one, The current shall be 100 amperes per inch minimum, 4 amperes per mm. Same thing divided by 25.4. So it's thinking 25, so it is 4 to 125 maximum ampere per inch. So that is 5 amperes per millimeter. Up, broad spacing for section 3 by 4 inch, 19 mm thick or greater. For sections, broad spacing per inch, this is a inch or mm, but this is the thickness 19 mm thick or greater. If it is less, it becomes 90. So that is the difference. Less than 19 mm thick, the current shall be 90 ampere per inch, 3.6, and 110 amperes. So 10 plus 10 minus this taking. And just remember that way. And 4.4, 3.6 to 4.4. That is 4 to 5 per mm upright spacing. But the thickness is less than 19 mm or 3/4 inch. That is greater than 3/4 inch. The prod spacing of less than 3 inch 75 mm are usually not practical due to bonding of the particles around the prods. So it is interference of the particles, too much interference with each other, closing near each other, and it is bending this magnetic fluxes because it is circular magnetism. Longitudinal magnetization. Long parts shall be examined in sections not to exceed 18 inch, 450 mm, and 18 inch shall be used for part L for calculating the required field strength. So any field strength you calculate, you have to take 18 max. So that is max. After you have to take the second time. 9-inch both sides from the center. So part with L by D ratio equal to or greater than 4. So this is the first criteria. L by D, length by diameter ratio. If it is greater than 4, then ampere turns equal to current shall be within 10% of the ampere turns value determined as follows. So that is 35,000 divided by L by D plus 2 plus minus 10%. Now within the 10% of the ampere turns value determined as follows. Already seen, but still I am telling here. All the formulas you remember from that one, my book, and this one you just see the what is the difference and all the currents. You have to follow that book. Because that is the book from where they are asking, not from here. If you are answering from this, you can tell, okay, as per section 5, this, that, then answer from here. That is possible. But I don't know, because it is now, they are just checking the right answer by computer. I don't know how much they can help you. There is, of course, a system to tell that why you are thinking your means comment section is there. If you have time, you can attend. In our time, okay, there is too much time people giving. For comment, it is like after the exam, you write down comments. But now it is within the time. And it is 2 hour time for empty. So you have to complete within 1 hour, half an hour for your silly mistakes and half an hour for comment. 15 minutes and 15 minutes before you can come out. Parts with L by D ratio less than 4 but not less than 2. Ampere turns is 45,000 by L by D. So this is same. Part with L by D ratio less than 2, coil magnetization technique cannot be used. So this is important. Don't use. You cannot use it. If the area of magnetization extends beyond 9 inch in either side of the coil center, field adequacy shall be demonstrated using a magnetic field indicator or artificial plasms. If you can demonstrate, then you can do more. You cannot, then follow 18-inch and complete one length after another length. That is so simple thing. For large parts, due to size and shape, the magnetizing current shall be 1200 ampere turns to 4500 ampere turns. It is a common this. You don't have to follow this. You follow that book and this book. This here is the same. I think this is also same. Still, you see that that formula for that book. Amperes meter reading, ampere turns by turns. The 5-ton coil and ampere turns require 5,000. Use 1,000 amperes plus minus 10%. So within this also plus minus 10%. You already see 10%. Here also plus minus 10%, 30. I think this is also same. Circular magnetization technique, direct contact technique, head shot and central conductor. So that is direct contact. Magnetizing procedure for technique. Magnetization is accomplished by the passing current through the part to be examined. This procedure produces circular magnetic field. This is longitudinal magnetic field. This is circular magnetic field because current is directly passing. So it is circular magnetism and approximately perpendicular to the direction of current flow to the part. And the current shall be 300 amperes per inch, 12, that is 12 ampere per mm, to 800 ampere per inch, 31 ampere per mm or outer diameter. So I think that book is telling 1000 amperes directly, nothing. So follow that book. I don't know. I have to see that book. Let me see. This one is same and when prod is same, if prod is same, coil and I 45,000 is same, and this is for 35, 43,000. That is slight different, but 35,000 is same. The rest formula, another formula is there. That is the first one. Let me see through. Okay. I think there is 1,500 for central conductor. If it is less than 1 inch, 500, more than 1 inch, 1,000, 6,000 ampere for high thickness means the machine capacity, something like that. All these things are there. I will show you after all this. I will find out and I will show you. Central conductor technique. Magnetizing procedure for the technique of central conductor is used to examine the internal surface of crystalline, cylindrically or ring-shaped parts. Magnetizing current. The field strength required shall be equal to that determined for a singleton central conductor. The magnetic field will be increased in proportion to number of times of central conductor cable passes through the hollow part. For example, if 6000 ampere is required to examine a part using a single pass central conductor, then 3000 ampere are required when two passes of through cable are used. So 1200 ampere are required for 5 pieces used. That is for central conductor. Offset central conductor, that is slightly tricky. For current calculation shall be sum of the diameter of the central conductor and twice the wall thickness. So diameter you have to calculate like this. Sum of the diameter of the central conductor and twice the wall thickness. So that is the diameter. The entire circumference can be inspected by rotating the part, allowing the approximate 10% magnetic field overlap. That is 4D, but a D plus 2T, and you can say 4D plus 2T. We are calculating directly, or you can take 4D and rotate as you wish, because it is up to you, and check for the how much you can cover up. It is 3 times, 4 times, 5 times. You have to find out. Then comes yoke technique. Magnetic field strength. Only three-phase full-wave rectified current shall be used to magnetize the part. No, that is multidirectional. Yoke is different. Yoke is two-phase. This is for multidirectional magnetization technique. Three-phase used for multidirectional vector field. The Hall effect probe Gauss meter shall not be used to measure field adequacy of multidirectional magnetization technique. I'm just showing you what is necessary for you only. Frequency magnetic equipment with an ammeter shall be calibrated at least once a year. This is important. All procedure accuracy of units meters shall be verified annually by equipment traceable to national standards. NIST. They are telling NIST. Either here something different, but Americans they use NIST. Tolerance. The units meters reading shall not deviate by more than plus minus 10% of full scale. Light meter. Light meter shall be calibrated at least once a year whenever a meter has been repaired or when repaired. So each alternating current electromagnetic yoke shall have lifting power of at least 10 lb, 4.5 kg for AC at the maximum pole spacing. Lifting power of yokes with contact similar to what will be used during examination. Each alternating current electromagnetic yoke. Each direct current or permanent magnetic yoke, both either direct current or permanent magnetic yoke, have lifting power of at least 40 lb, 18 kg. So there is four pieces of 4.5 kg. Combine is 18 kg. So maximum pole spacing with these are all stamped and they are supplied by the manufacturer. You cannot just use from anywhere. And with they have their papers. Once you got paper, this weights there is no problem. You have the manufacturer's record. So that is because there is nothing inside. You can just bring it out. Nothing upon. So that is stamped once. So you cannot change it. Magnetic field adequacy Gauss meter. So Gauss meter is Hall effect probe Gauss meter or Gauss meter you can use, but shall be calibrated at least once a year. Or if you repair, major repair, then you change. Magnetic field adequacy, longitudinal, circular, magnetic, multidirectional. Field adequacy, to check you need bicep magnetic particle indicator. Suitable field strength is indicated when a clearly defined line of magnetic particles form across the copper face of the indicator when the magnetic particle are applied simultaneously. So this is coming on the top copper plate, copper plating surface. 8. So this is 8 pi shaped 8 1 2 3 4 5 6 7 8. So 8 pi shaped is ferromagnetic, but it is not. You can say just ferrite thing. It cannot just keep the magnetic inside. So with mu is mu about very low, no low permeability still, and they are just barraged together. And these are non-magnetic, non-ferrous trunnions and handle. So you see the barraging indications on the top, but top side totally covered with copper plating, and different dimensions are there. You just follow that. I am not going to full detail of that. The pi type indicator are best used with dry particle procedure. Just remember this, okay? Artificial flow sims. So one of the sims shown in the figure 7464 2. So this one or this one is the permacastrol strip. Above are example of artificial flow sims used in magnetic particle inspection. System verification not drawn to scale. These sims are made of low carbon steel 1005 steel foil. The artificial flow is etched on machined on each side of the foil to depth of 30% of the foil thickness. Then there is a coating brass about brass coloring. So wet particle concentration and contamination. So what they tell, seam type indicators are best used with wet particle procedure. Hall effect tangential field probe, a Gauss meter and Hall effect tangential field probe shall be used for measuring the peak value of tangential field. For normal fields you can do. For multidirectional you cannot use Hall effect tangential meter. A suitable field strength is indicated when the measured field is within the range of 30 Gauss to 60 Gauss or 2.4 kiloampere per meter to 4.8 kiloampere per meter while the magnetizing force is being applied. Magnetic field direction in the desired direction or at least two nearly perpendicular direction for the multidirectional technique. Even we are checking diagonal to each other, that is two di in two directions. So wet particle concentration, contamination. So this accomplished through the use of pear-shaped centrifuge tube with a 1 ml stem, 0.5 ml division. The fluorescent particle suspensions of a 1.5 ml stem, 0.1 ml division for non-fluorescent suspension. Appendix X5. Before sampling, the suspension should be run through the recirculating system for at least 30 minutes and ensure thorough mixing of all particles which could have settled on the sump screen and along the side of bottom of the tank. Concentration: take a 100 ml portion of the suspension from the hose or nozzle, demagnetize and allow it to settle for approximately 60 minutes with petroleum distillate suspension or 30 minutes with water-based suspension. So there are two things, so you have to follow that thing. 1 hour for petroleum-based suspension and 30 minutes for water-based suspension. So this is another type of SIMS, SIM type CX230, CX430, CX. These are all for circular magnetisms. I'm not going to that too much. It is not needed. For fluorescent particle, the required settling volume is from 0.1 to 0.4 ml. And there is plus minus of 0.05. We already seen. In a 100 ml bath sample and from 1.2 to 2.4 ml per 100 ml a vehicle for non-fluorescent particles with plus minus zero point 0.1. We already seen in the book. Contamination. Both fluorescent and non-fluorescent suspensions shall be checked periodically for contamination such as dark scale, oil lint, loose fluorescent pigments, water. In the case of oil suspension and particle agglomerate, which can adversely affect the performance of magnetic particle examination process, the test of contamination shall be performed at least once per week. So these things you have to remember: once per week, once per day. So all these things are monthly, weekly, yearly. They will ask. The liquid will have a little fluorescence. The color can be compared with a freshly made up sample using same material with an unused sample from the original bath that is retained for this purpose. The used sample is noticeably more fluorescent than the comparison standard. The bath shall be replaced because the particle is coated with fluorescent, not the medium. So if it is transferred to the medium, then you have to change it. The graduated portion of the tube shall be examined under the fluorescent excitation light. The bath is fluorescent and under visible light, both fluorescent and non-fluorescent particles for the striation of bands, difference in color or appearance. Bands or striation may indicate contamination. So ketose ring or beige ring, we already seen. Material, the ketose ring, tool steel ketose ring should be machining from AISI 01 material, the accordance with the T766.1. Either the machine ring or the steel blank shall be annealed at a 1650 degrees Fahrenheit, 900 degrees centigrade, cooled to 50 degrees Fahrenheit, 28 degrees centigrade per hour to. So it is so slowly you have to cool 28 degrees per centigrade per hour to 1000 degrees Fahrenheit, 540 degrees centigrade, and then air cooled to ambient temperature. So from 900 you go to 540 and then you can go for air cooling, and the rate of cooling is 28. Same rate of heating is there. They had not written, it should be written. Same, you can follow 28 degrees centigrade. If this is perfect, then you will get the actual ring, actual properties. The air cooled to ambient temperature to give comparable results using similar rings that have had the same treatment. Hardness of 90 HRB to 95 HRB alone is insufficient. So this is we will get, and after the other things has to met. So AC passing through the central conductor at a 1 inch 25 mm 30 mm diameter hole located in the ring center. The conductor should have a length greater than 16 inch 400 millimeter. The current shall be 1400 to 2500 ampere, 3400 and 34,000 ampere. The minimum number of holes shown shall be 3, 5 and 6 respectively. The ring edge should be examined with either black light or visible light depending on the type of particles involved. If that, so 3, 5, 6 if you are looking, okay. The test result not revealed the required number of holes, the equipment shall be taken out of service and the cause of loss of sensitivity determined and corrected. This test shall be run at least once per week. This is weekly test by Kito's ring. Preliminary direction of magnetization. You can check with the field spy gauge or SIMS. Dry particle, the magnetizing current shall remain on while the examination medium is being applied. So for dry particle, the magnetizing current shall remain on while the examination medium is being applied. Wet particle, the magnetizing current shall be turned on after the particle have been applied. So you apply after you turn on this. Here continuous to do it. So you say 359. If you see this 359, so maybe 3 for the thing, I don't know. Just anything still we have to. The minimum light intensity shall be 100 foot candle 1076 lux because it is 10.76 lux 1 foot candle. Now they changed, before it is 1000 lux, it is 1076 lux. Fluorescent magnetic, that is for visible. This is for fluorescent magnetic. So it shall be performed in a darkened area with maximum ambient white light of level of 2 foot candle 21.5 lux. Measured with calibrated white light meter at the examination surface. Examiners shall be in a darkened area for at least 5 minutes. Examiners shall be at a darkened area for 5 minutes prior to performing the examination to enable their eyes to adapt to dark viewing. Glasses or lenses worn by examiners shall not be photosensitive. You cannot use photosensitive lenses or glasses. Other glasses recommended by manufacturer for UV 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 glasses means non-UV glasses they are supplying. It is written, I think I remember there is from the manufacturer you can use that. The examination area shall be illuminated with UVA light that operates in the range of 320 nanometer to 400 nanometer. So when you filter this is the 320 to 400 you are getting. So with this light also, if you directly see, your eye will fluoresce. Fluoresce means you cannot see for that day. With small, so less, if it is less than 320 by broken filters and all, like if you see colors, your eye will be damaged. So UVA light shall be achieved with a minimum 1000 microwatt per centimeter square. On the surface of the part being examined throughout the examination, there it is given above 15 millimeter above the surface that you have to follow. So reflector filters, glasses and lenses should be checked and if necessary cleaned prior to use. Checked or broken reflectors, filters, glasses or lenses shall be replaced immediately because otherwise you will just damage your eye. The UVA light intensity shall be measured with a UVA light meter prior to use. Whenever light power source is interrupted or changed and at the completion of the examination or series of examination. Mercury vapor arc lamp produce UVA wavelength mainly at a peak length of 365 nanometer. This 320 to 400 and peak is 365. Remember all these things. LED UVA source using single UVA LED or an array of UVA LEDs shall be emission characteristics compared to those of other UVA sources. LED UVA sources shall meet the requirement of AC 2297 because now LED UVA source are coming. That's why they added this part. Okay. So no need filter and all, but the requirements you have to follow. That should be certified as per AC 3022. All these things are there. So fluorescent magnetic particles with other fluorescent excitation wavelength. Examiners shall be in a darkened area for at least 5 minutes prior to performing examination to enable their eyes to adapt darkening. Glasses or lenses worn by examiners shall not be photochromic or exhibit any fluorescence. If the fluorescence examination light source emits visible light intensities greater than 2-foot candle, the examiner shall wear fluorescence enhancing filter glasses. So that is the fluorescence enhancing filter glasses approved by the light source manufacturer you can use because they are using more than 2-foot candle. Non-rejectable indications shall be recorded as specified by the referencing code section. Demagnetizing you will have to do, post-examination cleaning you have to do, evaluation, looking for evaluation, go for different codes and you have to accept or reject. Okay, that I'm not going to tell you. Rejectable indication shall be recorded as a minimum. The type of indication, linear rounded, location and extent, length of the diameter of a line shall be recorded. The requirement of Article 190A, T90A, magnetic particle equipment, types of current, magnetic particle visible or fluorescent, wet or dry, map or record of indication, material and thickness, lighting equipment. So mandatory appendix, what is important? Requirement of AC yoke technique. It is about the same. Identification of surface configuration to be examined, including coating material, maximum qualified coating thickness and product forms, base material, welded surface. Surface conditions, requirement and preparation method, manufacture. and model of SEO, manufacture and type of magnetic particle. So these are you cannot change essential variable. The minimum and maximum pole separation, identification of steps in performing the examination, minimum lightning intensity, SEO clipping power requirements as measured in accordance with technique qualification, method of identifying the flaw indications and discriminating between the flaw indications and false or non-relevant indications. These things we already see in the book, so I am not going to all these things. Instruction of identification and confirmation of suspected flaw indications, applications other than powder blur. And the remaining four method of measuring coating thickness, recording criteria, personal qualification, reference to procedure qualification records that are non-essential. If essential, you have to change the procedure. The magnetic technique shall be in accordance with SD 7091 standard practice of non-destructive testing, coating thickness measurement, and you measurement of dry film thickness, non-magnetic coatings. Coating thickness measurement shall be taken at the intersection of 2-inch maximum grid pattern over the area of examination, at least one half of the maximum yoke length separation beyond the examination area. Thickness shall be mean of 3 separate readings within 1/4 inch, 6 mm of each intersection. So technique qualification, a linear indication not length of 1/16 inch. So if it is not, you have to go through this document. I am just telling the important things. So this may be accomplished by holding the yoke with a 10 lb, 4.5 kg ferromagnetic weight between the legs of the yoke and adding additional weights calibrated on postage or other scale until the ferromagnetic weight is released. That means for everything you have to performance means qualification, procedure demonstration you have to do, identification of procedure technique, description of drawings, sketches, qualification of specimen including coating thickness measurement, flow dimension, equipment and materials used, illumination level, yoke lifting power, qualification results including maximum coating thickness and flows. If you want to keep it. If you don't want to keep it, that is so simple. So if it is requirement of SC or HWDC yoke technique with fluorescent particles, these are the requirement. Identification of surface configuration to be examined and product form, base material and welded surface condition requirement, preparation method, yoke manufacturer model, particle manufacturer designation, minimum and maximum pole separation, identification of steps in performing the examination, maximum white light intensity, black light intensity, personal qualification requirement, reference to procedure qualification records. These two is non-essential. This is for qualification alternate wavelength light sources. This is for light sources. The black light intensity of the examination surface shall be adjusted measuring the distance power so that there's a minimum intensity of 1000 microwatt per centimeter square, maximum intensity of 1100 microwatt per centimeter square. Requirement to qualify alternate wavelength light source for excitation of specific fluorescent particle. Particle manufacturer designation, carrier manufacturer designation, alternate wavelength light source, manufacturing model, alternate wavelength light source meter, manufacturer model, filter gas if needed, minimum alternative wavelength light intensity, qualification records, no, non-essential, all these essential, and documentation. Alternative wavelength light source, manufacturer model, wavelength light source meter, manufacturer model, filter glasses when necessary, fluorescent particle manufacturer and designation, qualification standard, identification technique details, identification of personnel performing and witnessing the qualification equipment and material used, minimum alternate wavelength light intensity, black light and alternative wavelength light qualification, photos, exposure setting, and filters if used. Requirement of use of magnetic rubber technique. Limited visual or mechanical accessibility such as bolt holes, coated surface, complex shapes, and poor surface conditions, discontinuities that require magnification for detection and interpretation, permanent record for the actual inspection, gauge meter or artificial sims shall be used for field strength and detection determination. Replica viewing may be aided by the use of magnification. Prior to magnetic particle examination, surface to be examined and adjacent areas within at least 13 mm. Half inch of the area of interest shall be dry and free of dirt, oil, grease, paint, lint, scale, welding flux, and other extraneous material that could restrict the particle movement and interfere with the examination by preventing the cure of or extending the cure time. Okay, tapping and damming. Tape, putty, plug, and other suitable means shall be used to form dams or encapsulation that will provide a reservoir or contaminant to hold the liquid or semi-liquid polymer in contact with the area of interest during the magnetization and until curing is complete. The horizontal through holes. Place the adhesive tape over the one side of the hole, making a pinhole in the tape at the top of the hole for release of air during the pouring. A cup open to the top side and fabricated for heavy aluminum foil may be attached with taper or putty to opposite side of the hole to serve as a funnel during pouring. Flat surface putty dams may be constructed around the area of interest to contain the liquid polymer after pouring. Inverted surface putty reservoir may be placed beneath the examination area and pressure fill the area with liquid polymer, allowing trapped air to escape by placing a small vent hole in the dam next to area of the interest. So after drying, you can the field strength shall be measured using gauge meter. Examination. So a minimum of two fields 90-degree apart shall be maintained for an equal amount of time during the cure time. The liquid polymer particle mix used. When more than two fields are to be applied, a minimum time in first direction shall be allowed before the magnetization in the next direction is applied. The same minimum time used for each subsequent magnetization. The cure time applied to each direction shall be based on the mixed cure time divided by the number of magnetic fields applied. Movement is not allowed during cure, avoided. So removal of replicas as soon as the practical after the cure by careful use of tool or compressed air. So examination record, sorry, evaluation. All indications shall be evaluated in terms of acceptable standards. Referencing code section following removal. The replica shall be examined visually in order to detect any damage to the surface of the replica. Where the area of interest shows damage or lack of fill or contact with the examination surface. The examination shall be repeated. When the dimension data is required, all illuminating magnifying device capable of making measurement shall be used. So for documentation, what do you need? Date of the examination, procedure, identification and revision, magnetic rubber mix, manufacture and identification, examination personnel if required by reference code section, map of the recorded indication for evaluation for T792, use type of power, magnification, material, thickness, magnetic particle equipment and type of current, Gauss meter manufacture, model, serial number or artificial seam used, field strength, if Gauss meter is used, duration and total time of application. When more than two fields are applied, number of sequencing of the application and temperature. Okay. Non-mandatory impedance say measurement of tangential field strength with Gauss meter. Frequency response of a Gauss meter shall be at least 0 to 300 Hz. The Hall effect tangential field probe shall be no larger than 0.2 inch and should have maximum center location 5 mm from the part surface. I'm sorry. Okay, we'll stop here.